Hey guys, welcome back to another video. Bitmaster Zor here. So in this video was requested by one of our followers, Ronnie Sozi, if I'm pronouncing that correctly. And he wanted me to essentially show how we could perform specifically a reverse SOCKS5 proxy in Delphi. Now, the thing about this is that I'm currently working with another gentleman on this to be able to complete that specific goal, like in its own kind of project, if you will, which is just specifically SOCKS 5. However, in this video, we will actually be achieving that end goal by using SSH reverse tunneling. And we're going to be doing this natively inside of Delphi, which means there'll be no dependencies of any kind. Everything will run exactly as it's supposed to for the operating system that it's compiled to run on. By the way, this project can be cross-compiled to run on pretty much any OS on the planet. So again, Delphi, very powerful computer programming language. Highly recommend it to anyone. But anyway, let's get started. So we're going to be doing SSH stuff. So in a traditional SSH setup, you would have basically the internet, and on one end of the globe, we'll say this is supposed to be like a, the person's internet, or the person, the server, the whatever you're trying to get into and use their internet connection to browse the web, right? So you can browse the web using their internet connection. It should be able to send it through the internet back to you, whatever you requested for, like www.google.com or whatever. This is what we're going to be achieving. Okay, so we're going to be able to have them make an SSH connection to us, and then we're going to be able to open up our web browser, and we're going to be able to type in a website and hit the go button or whatever, and it's going to make that request through the already existing tunnel right here. And then their SOCKS right here, their SOCKS service is going to grab that requested website and throw it back through the tunnel all the way back to our web browser. So just so just so I've made this abundantly clear, this is what we're achieving, okay? But I'm going to take all this out, and we're going to go back to a basic SSH format here. So we're going to talk about SSH. We're going to talk about tunneling through SSH. We're going to literally try to cover every single aspect of this that we possibly can. So in a traditional manner, in a traditional sense with SSH, you'll have a client, and then you will have a server. So this will be our server. It's a big server, right? With an S for server, right? So remember, this is all SSH. So this is the SSH server, and this is the SSH client, okay? Now, on the server side, you're going to have a router, and you have to be port forwarded. Even if it's wireless router, you're going to have a port forwarded for yourself, obviously. So let's just say that we use the default port 22, which I never do, by the way. I always mix it up and use different ports. That way people can't guess trash. But anyway, so what happens is that this gentleman here, whoever he, she, whatever is, they would connect to this port 22. So they would connect on port 22, and they would have to know your IP. Your IP. So let's just say your IP is like 1.1.1.1. Just whatever. It's fake, but whatever. Let's say that's it. So they would have to connect on 1111. They would have to connect to your IP using your IP, right? On port 22. And they would establish a connection through your router because you port forwarded, and bingo, they come into your server, and it stops them right here at the SSH server point. And what has to happen now is that the server has to transmit a key, like a certificate for encryption. So what will happen is that it will send that back through the socket, and they will get it on their end. Usually what will happen is you'll get this big pop-up window, and it'll have a bunch of info saying, hey, this certification may or may not be trusted, blah, 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 blah. And then you'll have some buttons down here The buttons will be for accept, decline, or cancel, or something like that. So you usually have to click on the accept certificate button. And once this is done, a command prompt or an SSH window will open up like so, if you don't already have it open, and it will request login information, user, and if you have this turned on, it'll ask for user, and then it'll ask you for your password. So this, you'll have to type in both user and pass and hit enter, and then you will be presented with the shell down here. It'll just come in, and there you go. You'll be shelled into the SSH server. That's essentially how it works. So there's 3 pieces to this, guys. Okay, step 1 and 2 and 3. So step 1 would be accepting the certificate. So I'm actually just going to type this out. Accept certificate, and I'm going to put SSH server certificate. And then step number 2 is type in username, and then step 3 is type in password. So guys, I'm actually going to show you how this is done, how every bit of this is done programmatically in Delphi. So don't worry. And if this is all too much for you, if you're thinking, oh man, dude, you're drawing all over the place, I don't get this shit, just relax, okay? Just take it easy, because I'm going to go through every single bit of this in code and out of code. So to start off with, I am going to start up a quick project that I have here. This is my SSH server control panel. So I'm just going to run this. We're not going to look at any code, okay? I'm just going to click run, and we're going to wait for it to pop up. And as you can see, my SSH server is now active on port 3434 in my Delphi program. Now, I don't use any external dependencies, guys. This is a fully blown SSH server supporting pretty much every protocol you could imagine, including, of course, SSH. That's what it is. So what we'll do is I'm actually going to open PuTTY. So let me pull this over. So this here, so you can stick with the drawing. I'll put this over here, and I'll put this is going to be our clients, right? So we're not even coding in Delphi yet, guys. I'm just showing you like visually how this would work, right? So I would have to connect to my local host. Now if you notice, my SSH server is listing on 3434. So what I'm going to have to do is type in 3434. And then I'm going to leave it as an SSH connection type. Now later, guys, we're going to go pretty in depth. We're going to come down here to the SSH portion, and we're going to talk about tunnels, which is right here. And we're going to talk about local, remote, and dynamic tunneling. But we're not going to go that far yet, so just be patient. We're going to connect to a basic SSH terminal. That is all we're trying to do, okay? So we have our local host typed in, and we have our port that we're going to connect to, and we're going to open it, okay? Now, you see this right here? I just got a message on my screen that says, warning, potential security breach. Remember this message I told you about, guys, over here? Remember this one right here? About, oh my God, you need to accept this shit. Oh, there you have it. This is this is asking that you request the RSA2 key fingerprint here for this server. So I'm going to obviously click accept. And now in PuTTY, it's asking me to log in. Remember how I told you the user pass down here? Remember that, guys? Remember that right down here? This is the third step, the second and third step. So I have to log into this server. So I'm just going to type in user and hit enter, and then my password is just pass, so P-A-S-S, and it doesn't type, but I can assure you it's an interactive keyboard, and it is actually working in the background. So I typed in P-A-S-S, and now I'm going to press enter. And as you can see, I am now inside my computer, and I have a reverse shell from the client, from the server to the client. So I can basically, I can do whatever I would like. You see, I can CLS it, I can clear it, exit it, whatever. I'm inside the server, the SSH server, and I can do whatever I would like. Now, this is a basic SSH connection. Like, you were able to make a connection from the client to the server, and you're in. and you can see all this stuff, and you can do all this stuff, and there you have it. You're in the SSH server. You can now execute any commands you would prefer. Now I'm going to close out of this, and as you can see, I both connected and disconnected from my local SSH server that I have running in Delphi. Now, this is the traditional way of it. Okay, this is how SSH works. You have to have an SSH certificate. You have to have the username and password if you have that enabled. If not, there are other authentication methods. We're not going to cover them because we're going to keep it super simple. Because the gentleman who asked me to make this really would prefer to keep everything off the disk, as it were, because I'm sure that he's doing this for IT security purposes, and we don't want to write anything to disk, which is the best part, because we're actually, by doing it this way, believe it or not, and you guys are really going to flip over this. Some of you guys that do SSH stuff, you're really going to flip over this. These SSH server certificates usually get saved as a certificate on, like, for example, Microsoft Windows. That's not what we're doing. We don't have to worry about that bullshit. The SSH server certificate, we're actually going to hold it in RAM temporarily. We're not going to allow it to touch the disk. We are not going to allow it to touch anything. Every single time our SSH server is ran, it creates a new certificate in memory, and we can change the username and passwords in whatever way we see fit, which is the best part. Also, the usernames and passwords are also not saved to disk. Everything is held in RAM and is only valid for one session, and that is it. Now, when I say one session, I mean the entirety time that the server executable is actually running. From the moment you hit the close button or cancel out of it or kill the process or whatever, all of these things here will simply just go bye-bye forever, permanently. Just whoosh, like they never existed. All right, so now that we understand how to work with SSH, I'm going to Control-Z the crap out of all this, okay, guys? So here, I'll tell you what. Let me just make a new, and I'm not going to save this. Sorry for the blindness of that, guys. I'll try to make that black again, and I'll just use a pencil or a brush or something. So okay, so now that we have this, let's go with this, I guess. So now that you understand SSH, how simple it is, the server has to, in order for the server to start, the server has to create a key, like an SSH certificate, which will contain both an encryption key, private and public. It'll also have a user and password, and that's pretty much it. So let's go ahead and again, let's just talk a little bit here concerning what it is we're going to do. So again, as I've stated before, this will be the person that you're trying to use their internet, right? Because this is going to be a reverse tunnel, and we're actually going to put RT. So for reverse tunnel, okay? So what'll happen is at your computer, you will start up an SSH server, and we'll just say that's on port 22, okay? And this person, if they're behind a NAT router or whatever, you know, at work or whatever, you'll have the same, probably similar setup these days, right? You'll probably be behind a NAT route wireless router as well. So yours will be port forwarded though to 22, so yours will be open to 22, so you can accept connections, right? So what's going to happen is this dude over here is going to start up his little executable, his little SSH client, and it's going to connect through his router on port 22, get to your router, and be forwarded right into that, and it'll go right to 22. And then he's going to be presented with all that stuff that I tried to let you guys know about. Remember, he's going to be prompted to accept the certificate. He's going to be prompted to type in a username and a password. However, you may have a case scenario in IT cybersecurity where you don't want them to see that shit, right? Hell, it could be for a server. It could be for, well, anything, right? Any purpose where an end user doesn't need to know what's happening in the background for something to work. So we want to hide all this stuff from this person, because they may not work in IT. I mean, let's face it. They may not work in IT, or you know, whatever else you're doing, right? So wink, wink. So basically, this person right here, um, the thing will happen in a background type deal where it receives the little warning and it automatically accepts, and then it automatically goes down and types in a username, and then it automatically goes down again and types in a password, and then it automatically goes down and it gets the shell in the background, which the user won't even see or have access to. But now you can actually manually or automatically type stuff in here, or with the component library I'll be showing you guys, you can actually tell this to say, hey, I'm going to do something special here. And so what the client will do is you could actually start up, after this, you could actually start up your very own SOCKS, so SOCKS5 proxy. So you start your own SOCKS5 proxy listening on port, for example, 8888. Sorry for my look there, guys. It's pretty bad, but so let's say that the SOCKS proxy is on 8888. But here's the thing. Here's the thing. You guys are way off on the other side of the planet, and they're way off over here. Now look, they do not. Obviously, this person is either dumb, not IT, or has no freaking clue what's going on, right? Because again, and whatever, even if this was for an automation platform, you know, for legal purposes, you may not want that person to have to deal with all these configurations, which is fine, because now that they've got a SOCKS5 proxy server listening on 8888 on their local host machine, what you do is you have the console or this process ask, like, send a data packet like through the router, through their thing to port 22, requesting that your server, your thing that runs the whole server thing, the application that is hosting the SSH server, you say, hey, I need a favor. I need you to, I'm requesting port forwarding from you on gateway ports. Now I want you guys to keep this in mind. It's called a gateway port. So we have a gateway port, forward request. And we're going to request that this be forwarded, say like on 5933 port, okay? But remember, guys, down here where where it's asking the favor, like where it's coming up, like where it says right here where it sends the data packet up through here and it asks for the favor to port forward on 5933, it's also putting in 2 ports. So pay attention very closely, guys. It's going to ask a favor. And the favor is, first of all, on its side, it's going to start kind of it's going to create a forward request on its own side as well. Well, not a request. It's just going to do it. Okay. So like, for example, it's going to open up a port 5933 to that tunneled port 8.8.8.8. Okay. So now the server side will say yes. Okay, I'll do that for you. Check mark. I'm going to do that for you. Absolutely, I'm going to do that for you. So what happens is now any data on the server side that goes through port 5933 is actually going to go through the tunnel, okay, through 22, and it's going to go all the way over to the client side, and it's going to make it through because it's going through port 22. So that's already established. You see that, guys? So when it gets over here, it's going to come through the router, come down here, and oh, looky here, looky here, looky here. It's going to actually go through 5933 and that's going to be forwarded. Whatever data came through to be able to go to that port from 22. So it goes from 22 to that port to that port. You get it? It's kind of a weird mix-up thing, but this is reverse tunneling, and this is the nature of it. And gateway ports have to be enabled on both sides. On both sides, gateway ports have to be enabled because these right here are gateway ports. They're gateways to other things. So whenever we request it, I'll say this again. We request information. We request, hey, look, what we're saying is we've got a particular situation here where we'd like to forward a port to another running service on our side. So can you please port forward, for example, 5933? And then the server says, yeah, sure, why not? So 5933 gets created, and now the server is actually, believe it or not, in the background of your Windows computer, or any OS that you're running, by the way, it actually is listening on port 5933 for incoming connections. Now, just bear with me, guys. Don't be confused yet. I'm going to go over this again. So your server is actually listening on 2 ports now. It's listening on 22, which is the default SSH port or whatever you had set up. But it's also got a gateway port listening for data on 5933. Now, any data that comes in through port 5933 goes over the socket connection through the SSH tunnel over to the client, which now has forwarded from 22 any data that comes in on a port that's bound to go to 5933 actually goes to port 8888. So this is where your proxy's doing all of its magic, right? So get this, guys. There's one extra step. You open your web browser on the server side. Oh God, this is a terrible window. But you get the point. There's the X, there's the minus sign, whatever. You guys get it. Type in, you click on the setting thing over here, and it pulls open the window for your SOCKS proxy information, and you want to use localhost and this port, 5933. Type that in right here, right? Then you type in www.google.com and click go, and what happens is that goes, all the data that you're trying to do goes to 5933. Right? So 5933 then takes the data from your web browser and requests internet access to whatever website you're trying to do using SOCKS protocol, SOCKS version 4 or 5, whatever you've got it set for. And it takes that data through the 22 port, which is already established via TCP and SSH and whatnot. TCP, by the way, is the underlying technology on that, just FYI. But it takes the data for the request for Google, comes over the wire, goes to the client. The client sees that data was actually bound to port 59, or bound for port rather 5933, and it takes that data. And instead, it takes it in on 5933 and forwards all that data to 8888, which is running your SOCKS server. Okay? So then the SOCKS server goes la 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 la, and it processes all the data and it parses all the SOCKS information and does all that information, and then it takes the website data that it gathered and throws it back through port 5933. And that so it comes down here and it throws it backwards through 8888 back to port 5933, which in turn then takes it back through port 22 all the way back to you, and it comes back through 22 and it comes right back to the port 5933 and throws it onto your web browser, the web page. You get it? So guys, I know this is, believe me, I almost went nuts programming it the first couple of times, like dead serious. I had to restart the project a few times because this can get a little bit wanky, you know what I mean? But once you have it visually established in your mind, it's really super simple. And the thing that you need to understand about this is that essentially this is a RT on this end, a reverse tunnel request for port forwarding on the server. And on the server side of things, it's actually a DT, which stands for direct tunnel. Okay? So it's a direct tunnel to the client. It's a reverse tunnel from the client to the server. As long as you guys get this, it's super, super simple to grasp. Okay? So we're going to start looking at code now in Delphi to achieve this. But not only this, we're going to talk about direct, we're going to talk about reverse tunnel, we're also going to talk about dynamic. So let's pop this up in Delphi. Now I have two projects. I have an attacker and a victim. And I named them that because this is an IT security channel, and I just want you guys to understand and visualize that if this was the victim, this needs to be labeled victim, okay? And this is the attacker, right? So this is all concept stuff, right? Practical concept, but we're going to go through it, and I'm going to show you that this does work in the exact method that you are trying to get to achieve. So the SSH server control panel, so this is just a server, okay? And the victim acts as an SSH client, okay? So understand this. We have on the server, we have a server component that's going to be hosting our SSH server. We have a memory storage where all of our usernames, certificates, all of our SSH information is going to be stored only in RAM. This is the really cool part. Now, for those of you out there who are building business software, let me go over here real quick. For those of you out there who are building business-related software that really needs to work behind say like a business firewall, and you're doing this for legitimate purposes, and this is not, for example, for IT cybersecurity education, you guys are going to want to use the file storage or even the registry storage or even the crypto API storage. One of these, most likely the file storage being the most simplistical, you would want to use that. But in our specific case, we do not want to leave traces of anything on a potential, what we would call a victim's PC. That's why we're using memory storage, so that everything stays in RAM and it gets wiped away as soon as the application dies out. So there's that. And basically, we're going to proceed. So for this side, obviously the client, let's talk about this as well. So again, we have memory storage. Again, the only difference is that on the client side, we also have a SOC server. So let's go back over this just real fast. Let's start back with the server. So on the server, we have an SSH server. We have the memory storage unit where we're going to be storing all of our stuff in memory, only memory. We also have an SSH client, which is going to be held locally for the other port. Now remember, guys, if we look in Paint, remember how we have the 5933? Well, and on the client or victim, whatever you would like to call it, side of things, we have 5933 to 8888. These are gateway ports. Now, pay very close attention, guys. We have to have two pieces of the puzzle here. There's three pieces to the puzzle. There's the client side of things, and then there's the server side of things, but there's also a thirdly, and that is a client that's on the server locally, which can actually act as a direct tunnel, so that we can, well, it's kind of like acting as a dynamic port, if you would, but it's not really dynamic. We're using direct tunnel, but it makes it to where you can connect your web browser to this application, and it'll pipe the SSH client here will pipe all of your web browser's traffic through the server, and the server will forward that information through the requested port forwarding that the client requests to the client itself. And that client will take the channel, throw the information through the channel through our hosted SOC server here. And then the SOC server will grab the website, forward the data to the channel, forward that data obviously to this client thing, and then this client thing sends it back over to this channel, and this client, well, actually it comes through the server first, then it comes through this, then it goes to your web browser. You kind of get that. It's a simple flow. You just have to get the flow in your mind, okay? So, and again, by the time this video is over, you guys will probably completely understand, because I will be covering it multiple times, just in different ways to try to get the exposure for people out there to try to understand how this works. It's really super simple. I mean, anyone who's ever worked with SSH before, I mean, come on, it takes literally 5 seconds to do this without code. I mean, all you have to do is type in -R, the IP to go to at whatever port or whatever, and then at the end user at whatever, and hit enter, and boom, you're done. Like, literally, it's that simple. So if it can be done in 5 seconds on a terminal shell or a command prompt, coding it with these components can be a little bit more complex, but it's the same technology, guys. Same tech, same stuff. So let's start with the server, okay? So when I run this program, the first thing I want to do is start up my SSH server. And by the way, before we take this any further, guys, just so you'll know, we are using the Secure Bridge SSH component suite. So if you guys are confused about these components, it's called Secure Bridge, and I found them to be some of the most amazing SSH components available for the Delphi programming language. Now, there's thousands more out there you could probably go and look at, but with these, it just really simplifies things down, and I love the company. I think it's made by DevArt, which also created a lot of different components for both Pascal as well as .NET as well. Um, but they have a really good reputation, and I can see why. But anyway, okay, moving on. So whenever this program runs, we're going to go to onForm create, okay? And what we have to do, remember how in Paint I told you guys there were steps up here, 1, 2, and 3. The steps for 1, 2, and 3 are simply that. Hang on just a second there. So basically, what you'll have to do is you have to set up a key. You have to generate your SSH server key. Then once that's generated, you have to create a default user credentials for your server so people can even log in. And then after you've set these two things up, you have to also start the server. So let's go through this step by step, okay, guys? I'm just creating a key, which is a TSC key type, okay? And guys, if you're confused, this is all part of the Secure Bridge library. It's all documented, okay? So like in the uses statements up here, you have to have SSH utils, SC utils, SSH server, SC bridge, SCSH channel, client, and that's about it. I believe that is actually all you need. Just make sure you've got all of these added, and you won't have any problems adding this stuff at all. So I'm creating a new key, which is a TSC key, so a T secure bridge key, and then I'm creating a new key name, which is a string, which is just a whatever we want, right? And then I'm adding a user, which is a TSC user, which probably stands for secure bridge user, right? So we come down, we say, here's the new key name, and I'm going to call it key 1. Guys, I'm making it super simple. Super, super simple. So we start with a key name. We set that key to create itself inside of memory storage 1's keys. Okay, so if we go to the memory storage and we double click it, I want to show you guys this. It has a little graphical interface, which is really cool. You have keys, users, and certificates. Now, in our situation, we're actually only using keys and users, and we're not messing with certificates at all. Okay, so we're just going with keys and users. So we're making a new key. We're calling it a name, we're giving it an algorithm and all this and that, and we're telling it to generate itself, which will generate its own fingerprint, and we can export that key or import a key from, or export a key if we wanted to. We're not really doing any of this. We're making it super simple. And as with the users, we can add a new user with a username, a domain, a password, all of their authentication methods that they can use, which we're going to use password. And we're also going to enable SSH channel permissions. We're going to give them all permissions so they can do everything over that channel. And that's it. So basically we're making an admin user, if you will, okay? So again, we set the key name to key 1, because that's what our key is going to be called. We're creating it inside of memory storage 1 keys. The key name is equal to the new key name that we just created. We're generating by 2048-bit an RSA key. And that's it. This literally 4 lines of code. Boom, you're done. The key's created. That's it. That's all you got to do. And with these 4 lines of code, that's how you create a user. You just create user is equal to tsc user.create inside of memory storage 1.users instead of .keys, right? Users keys, right? So the username is equal to user, the password is equal to pass, and you can change these and make them whatever the hell you want. It doesn't matter. And then you just set the authentication to UA password. That's it. So this user can now be created and thrown in there, right? And this is exactly what happens. By calling this code and this code, we create a key and a user, and we throw them in there. And then we're going to start our server, because the server can be started now. The server will not start, however, if you do not have a key or a pass or a user. It won't work. It'll just error. So now that we have the SC Server 1 able to have a key and a user, on your graphical interface, you're going to want to make sure that that server is in fact assigned the storage of SC Memory Storage 1. So make sure you click on this and make sure that you have that storage selected. Otherwise, you're going to have problems, okay? So now we're going to start the server because we created the key, we created the user. It's time to start our server. We're going to set the server's port to 3434 in my case. We're going to set the key name for RSA equals the new key name. Now, the key name RSA is actually a property. So if you go to the server right here, key name RSA right here, you see this right here? You can't select anything because there's nothing in there because we programmatically did it. See what I'm saying? So I set the key name RSA is equal to the new key name, and we're going to activate the server to true. So the server will start listening, the server will create a SSH server listening on port 3434 with this RSA key. Okay, and that's it, guys. And then we can just simply output some lines of code or whatever, some string text, and say, hey, guess what? Your server works. Yay, congratulations. And that's it. That is literally the first step. So now the server is started, okay? Once the server is running, it's time to move on to the client code. So what you will want to do is, in order for this to work, and guys, it can be really confusing, it really can. Before you can start your 5933 stuff over here, someone would have to connect in and request forwarding on that port before you can actually do something with it over here. Because as you guys well know, if a client tries to connect to a server or a port that doesn't exist, obviously all you're going to get is a timeout error, right? Timeout, timeout, timeout every time you click a button and try to create a socket to connect to something that doesn't exist. You're just going to sit there and keep getting a timeout, right? It can really drive you nuts. It really can. This port forwarding through one single port type thing, it can be really freaking nuts if you're not careful. So this button, for that reason, I've disabled, because whenever the server event, so when the server gets a client connected, okay, that's when I say client connected from IP, and then I'm grabbing that remote IP information, right? However, later down the line, when that client, so when this person over here requests forwarding, so we can begin the process of using their internet on our web browser, the reverse SOCKS 5, right? When that does happen, we have an event down here called SSH Server 1 Remote Port Forwarding Request. It's a big, long word. That's crazy, right? And it's already programmed for us, by the way. I didn't program this. All I had to do was go down here. It's literally called On Remote Port Forwarding Request. Literally double click, boom, there you are. So first of all, allow is a Boolean. So we're going to allow the port forwarding request to be true. So we're going to allow port forwarding, right? And then we're going to say, hey, this client, whoever tried to request port forwarding, they requested port forwarding on this port. Is that okay with you? Like, you know, you could ask a question if you wanted to, but in this case, I just told it, I don't give a shit, just allow it. And then it enables the button to true. So as soon as a client connects to the server requesting that port forward, we're going to forward the port, and this button is going to become enabled. Now we can click the button. Now, when we click the button, it's going to create this thing so we can connect our web browser to it. You get it? You kind of get this so far? It's kind of weird, right, guys? So you click this button, and it's going to set your SSH client host name to yourself. The port is 3434, the user and password, because you have to be logged in with an SSH client into your own server so that you can have a channel to that server. And remember, we're going to enable gateway ports. We're going to turn remote false, dynamic false, and direct to true, because there's three different ways, three different main tunnel types when it comes to SSH tunneling, right? So I'll comment this. The remote type is used to reverse the connection from server to our client. Asks for port forwarding. Okay, and then dynamic, this is actually, believe it or not, and I don't want the asker of this to be confused by this, but generally this is used for SOCKS 5, used for SOCKS connections. Now, guys, don't be confused, because we're not going to use this. Even though we're achieving SOCKS 5, we're not going to use the dynamic port, okay? This is generally used for SOCKS connections, but it's a port that listens dynamically on your system to forward data to and from the server. It's about the best way I could describe it. If you turn dynamic to true and you connect your web browser to the port that the dynamic thing is attached to, which is going to be a source port, then you can potentially use the server's internet connection as a SOCKS 5 proxy, which is not the same thing as a reverse SOCKS 5 proxy that we're actually accomplishing in this example, right? So what we'll have to do in this last portion here, this is a direct tunnel. A direct tunnel takes from one port, we'll say 5933, for example, and sends it to another questionable port, whatever port we want. It's a direct tunnel from this port to this port, right? Whatever port we put here, right? That's what it means. This is direct, dynamic, and remote. In our case, this is on our server. We want we're doing some trickery here, guys. We're making it to where our server starts, and we're waiting for a connection from a client. So the client connects in from this program here, and they when they connect, they ask for port forwarding. And as soon as that port forwarding thing hits, this button enables allowing us to create a local port, and that's exactly what we've done. So now we can connect a web browser to our own server through this SSH channel and pipe all data through the source port of 5933 to the destination port of 5933. So we both listen and send on 5933. Now, I know it's a little bit to grasp. I know, guys. It's mind-boggling. I know. I get it. I get what you're feeling, because I had to program this trash, and it really bothered me a lot. But on the client side, they're listening on like they're connected to your SSH server on port 34, 34, or 22, whatever you want to call it, but they're also listening on another port that's hidden kind of underneath the initial TCP SSH connection, which is going to be 8888, right? So that is to say that you're receiving on your end from a source port of 5933, but you're also sending to 5933. The client side understands to wait for that. It understands that anything that comes on 5933 that you're sending to it, it's going to forward that to 8888, because that's where you have your secret SOCKS server listening for connections. Get it? So like whenever you connect and request that port forwarding, you're actually starting a listener on 8888 from 5933. So any data that comes from the attacker, the server side, to the client side on 5933 actually goes to the SOCKS server, and back and forth and back and forth and back and forth perfectly. So you literally browse the internet on the client's internet using their little SOCKS server thing that's now technically port forwarded through their router thanks to SSH. You kind of get it? We created a secure tunnel, a reverse tunnel for it. Really cool stuff, right, guys? So again, you create, again, I'll just go through this. So whenever the server starts up, we listen for them, and then they do all this and that. They will connect to us and request port forwarding, and then we will do that, and we'll create our own client to connect to ourselves, where we're going to be able to have our source port be 5933. Our destination host is obviously through our own server, which will eventually route all the way to the client, the victim anyway. So that's why we have to use 127.0.0.1 and 127.0.0.1 in both cases, because remember, we're using the server to communicate, and then we're going to connect. So now I'll have to take you guys over to the client code. So guys, we're on the client now, okay? So we've discussed how the server kind of works, right? Like it's really simple enough to understand. Now we're on the client. So when we start the server's listening. We're the client now. So when this opens up, we will try to connect to the server. So we click that button. This is the code. We're going to create an SSH client for the victim, or the client in this case, whatever you want to call it. The host name will be your server IP goes here. Now I changed this because this actually had my real IP typed in there. I didn't want you guys to see that. So you would type the IP of your server where they're going to connect to, which is the server of the computer of whatever the hell this is running on, right? And they're going to connect on 3434. They're going to type in the username and the password, and they're going to connect, and they're automatically going to accept everything, and everything's going to be happy hunky-dory. By the way, one other thing that I did forget to mention to you guys, on the SSH client, you have events. On server key validate, on everything you do, on both the server and the client, you need to be sure to go in here and write accept : true. So you guys remember that big thing that popped up that said, warning, this network could be like blah, 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 this certificate ain't valid, blah, 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 it may not be good, and I had to click accept on it. You want to make sure that on the event of your SSH clients, you're accepting that no matter what. So you just put accept = true. This is all you have to do, and it will automatically accept it silently in the background, and no one will see anything, right? Okay, so that's that. Now back on the client. So the server's listening. We're going to connect to them on whatever port, whatever host name they're at, and whatever port the server is mainly listening on. We're going to type in our username, type in our password, instantly connect, and everything's going to be happy hunky-dory. We're instantly going to be connected. Now, we're also going to start up a channel with gateway ports enabled. We're going to put remote is true because this enables remote forwarding. So by putting remote to true, we're asking the server, hey, can you open a port for us? You see that? And then dynamic is false. I also should have put another one in here and just made it false just to be safe. But I think it's false by default, so it's no big deal. Just leave it as remote, and dynamic is true and false. That's it. I could actually erase this line of code. It's not actually needed. But in any case, the source port will be 5933. The destination host will be our computer, which is the client, which is just its own local host machine. And a destination port will be 8888, which is our local proxy port, where we're going to be listening for proxy information. This is pretty cool, right, guys? You kind of get it. Super easy, right? Like, we're going to be accepting information from the server. We're going to be expecting it on 5933. And we're going to forward it, whatever comes in from the server, to 8888, which is our local proxy port. Any information coming in on 8888 is going to go back to 5933 and back through the main port of the SSH socket and get back to the person who requested it. Pretty cool, right? And if we have any errors, we're just going to add memo lines or whatever, which is stupid. I should remove that and say hide this secretly. But you get the point. So it's super simple. This is the whole client, by the way, guys. It's only less than 100 lines of code. And I didn't even write any of this. This is all auto-generated. The only things I wrote were try to this and one line of code down here, and that's it. That's all I wrote. This is amazing. Delphi makes things so super fast. I literally wrote the whole client in 2.5 milliseconds. No kidding. So again, guys, to come back to this again, and I'm just going to, here, let me go ahead and do a new, and go ahead and paint this black. Sorry for blinding you guys. But again, I just want to make sure that my followers are truly understanding this, okay? So you have a client and you have a server, okay? So the client is going to be the victim in this case, the person that's getting whatever dealt with, and they're going to connect to you with an initial tunnel. So let's kind of draw a little tunnel thing. This is the initial connection which is made with the username and the password and all that, right? And this tunnel is pretty big, okay? Let's say that it's pretty wide. It's got enough room for data to flow both ways, and it's also got, all kinds of room for other stuff to happen in here. We'll just color it nice and green. So it's a pretty big tunnel, right? It's got enough room in there for people to go camping and whatnot, right? So basically, what's going to happen is the client is going to request that it's going to send a packet of data through here, and that packet of data is going to get to the server, and the server is going to say, oh, okay, you're asking me to port forward for you, and that's fine. So we'll do that on 5933. And then on the client endpoint, it says, yeah, thank you so much for accepting my request. So it says any data that comes on 5933 is going to go to 8888, right? So then on our end, we open up a web browser. Okay, so this is your web browser, and there's the X and the minus and whatnot, and you're gonna go into your little settings thing here, and a little window pops out, and you're gonna set your SOCKS 5 proxy 5933, and that's gonna go to this port. So when you load up google.com or whatever, it's gonna go to this 5933. And that 5933 is going to go back through port 22 or 34 or whatever the hell you're listening on. La di da di da di da di da di da. It's going to go all the way to the client. It's going to go to 5933. Remember, because that's where we're listening at. And the client is going to say, oh yeah, we got some data on 5933. Let's forward that to 8888. Okay, well right now, nothing happens because we ain't got nothing going on. So listen carefully. So right now on the client, remember that little SOCKS thing I showed you? Here, let me go back. See this right here? This is a SSH right? So what we're going to do is we are going to make that SSH start listening. So this is an SS for SSH. That's the component. It's that little socky component thing. Okay, we're going to make it listen on 8, 8, 8, 8. And guys, I am so sorry for my thing there, but you get the point. It's listening on 8888. So it's going to forward to this component, which is listening on 8888. And this component is pre-programmed to understand the entirety of the SOCKS version 4 and 5 protocol. So it's going to go out to the internet using the client's internet, and it's going to get the website you requested, like blah, 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 like right here. And then it's going to take that website. It's going to reparse it through SOCKS 5 and whatnot, whatever data needs to be properly parsed for the web browser to read, and it's going to throw it back through 8888, and it's going to go back through 5933. So it's going to go back through 5933, okay, and it's going to go back through the main TCP socket connection 22 or 3434, whatever the hell your server is listening on, and it's going to come all the way back to 5933. And it's gonna go to your web browser. You're gonna see the website. It's gonna show up in here. You see? Pretty cool, right, guys? And that is how this sample actually functions. And it's gonna be really cool. So now that we've gone through this multiple times, guys, I really do hope that I've explained this well enough for you to understand. So on this side, we're going to continue with the client code, okay? So whenever we connect an SSH client, we're requesting port forwarding from 5933 to 8888. And whenever our channel actually makes a connection to the server, we're actually going to see that we're going to set up with 2 lines of code. We're going to activate our SOCKS server, okay? Our SOCKS server, our SOCKS 5 server. We're going to tell it that its default port is 8888 because that's what we requested forwarding to. And then we're going to set it to true so it starts listening on 8888. Now the cool thing is, the thing that most of you probably aren't realizing is that this component is not port forwarded because it's behind a NAT router and no one can get to it. But because of what we did with the request port forward through the reverse SSH tunnel, it is now exposed to the internet. You get it? Through port 8888, 5933 and 8888. So whenever we tell it to listen on 8888, it's actually listening safely behind a NAT router and a firewall and all this and that. However, thanks to our SSH connection and 5933 also being a port that is listening on through these components, we're forwarding the data from 5933 to 8888 internally for this client, and it's going to get the website. Like this component already has all the logic inside of itself to grab the website and whatever else you're trying to do and send it back through the port that it came from, which is 8888. In other words, when it throws it back through port 8888, it goes back through this, back to you. Pretty cool, right? So then we're going to just simply say we connected to our SSH server, the SOCKS server started on SSH forwarded port. Now, so let me give this a quick run. So we're going to run the server, okay? And I'm actually going to run both, guys. So let me run the victim here as well. So we have the server listening on 3434. Okay, on my localhost machine. We also have the SSH client connection here, which is going to just be responsible for connecting. So I'm going to click connect. Okay. Actually, let me go back to the code real fast because I forgot that I changed this. We're going to put 127.0.0.1, and I'm just going to run this again, and we're going to see it connect into the server. So if I click to connect it to our server, you see how it says that on this server side, what happened is it says, hey, someone connected from this IP address, and then, uh-oh, what's this? Oh, this guy also, he's asking to allow port forwarding on 5933. So the server created an internal localized port on 5933 that will now be forwarded to the client. And on the client side of things, it said, oh, he allowed it, so we're going to go ahead and also start our we're going to start our SOCKS 5 proxy as well on 8888. So now what I could do potentially is open my web browser, and here I'll do it for you guys. So like, let me just get this down where you guys can really see. And I know I'm doing this on my local host, so this really sucks. I may go ahead and do it on a different computer here in a minute just to prove to you guys that it does work. But if you go into your settings right here and go to like here, this is actually on Brave. Let me open Firefox. I'm sorry, guys. I'm kind of out of it today. But if you go to settings and then type in proxy and go to your proxy settings, see how I have it on localhost SOCKS 5. I could do 4 as well if I wanted to, but 127001 connecting to 5933 on SOCKS 5. Okay, so now anything and everything we do should go through that. I'm going to go, what's my IP address? And boom, you see how it shows my IP right here? So you guys can't see my IP, but I'll blotch out the beginnings of it, but you should see some numbers in there. That's essentially what it is. So it is working because we know that I'm forwarded through 5933 on 8888 on the client side. So we know it to be true and justified. Now I'm going to close this out, and I'm going to close both of these projects completely out. Okay. Now, I'm going to pause the video for just a moment so I can prep, and I'm going to show you guys that this does work on other machines anywhere in the world. Okay, so bear with me just one moment while I go ahead and set this up for an actual attack showcase. Okay? Okay, guys, I'm back. Now, pay very close attention. I know that you can't see what I'm doing on the opposite computer because it's across the world. I have it on a different monitor. I don't want to drag it to this one. There's a lot of stuff on it. It belongs to a friend. I don't want to reveal too much about this computer. However, understand that the server, this thing right here, is running on my computer. I'm only port forwarded on 3434, so this SSH server can be accessed from the internet. It's exposed, right? Which, as with anything in IT cybersecurity, generally you act as the server and things connect back to you in modern day times, right? Unless, of course, you're going to do some sort of weird mesh networking shit and you want to, like, use Tor or some crap to do stuff, but whatever. In any case, this is our situation. So the SSH server server is online on 3434. I'm now taking my mouse cursor and moving to the other computer. Now, inside the other computer, I'm double clicking on the SSH client connection, and it's up, and I'm going to click connect the SSH client to the server, the button. Okay, so I'm clicking it. You guys pay attention to the output log, and you're going to see that someone connected from an IP address, which I won't reveal the whole thing to you, but I am going to reveal some of it just so you guys know it's not my IP, right? Because you already saw my IP earlier in the video. I showed you part of mine. This one's different. And this person is asking for a port forwarding request on 5933. Now what we're going to do is we're going to take Firefox. So I'm opening up Firefox, and we're going to make sure that our settings are properly set for proxy, which they already are. We're on localhost, that's our computer, on 5933, which should be port forwarded through the forwarding request through SSH reverse tunnel on SOCKS 5 protocol. And we're going to go, what is my IP address? And as you can clearly see, it loads and it shows that IP address from the computer that we are browsing the internet from. So guys, that is it for this video. I really do hope that you guys enjoy the material that I come out with. Keep in mind that this type of traversing NAT is extremely simple. And I will also be making another video, hopefully in the very near future, concerning the ability to do this in a much more simple fashion. Like, this was more or less kind of an advanced tutorial because you have to understand SSH, and you have to make your own SSH server, and you have to make an SSH client, and you have to request port forwarding over it and make an actual reverse tunnel to be able to achieve this method of traversing NAT and making a reverse 5 SOCKS proxy on a client computer, willing or unwilling, wink wink. So basically, in the next video, I'm really hoping that I will be able to touch base on how to do this with raw socket connections instead of having to kind of be at the mercy of other people's written code and components and stuff. I'm actually writing kind of like my own raw version of just getting the job done as accurately as possible without the need to request port forwarding through an SSH tunnel, without the need for any of that crap. Essentially, one TCP connection will handle it all, kind of like one ring to rule them all type deal, right? So guys, again, I repeat, I hope that you really enjoy my videos that I come out with. I really hope that I don't waste your time. I'm trying to do this because I feel that we can help build up the programming community, the Delphi programming community as a whole, if more people are aware about this great language and just what it can achieve in a very simplistical way. So again, tell your friends about it. Please make sure to leave a like and subscribe to my channel if you enjoy my videos and my content. I will be coming out with tons more in the future. This is kind of a passion of mine. I don't intend to quit anytime soon. But sometimes life does get busy, so I'm sorry why this video took like 4 months to even come out with. I was in the process of writing other things and doing other things, but I do hope that you do enjoy. And just to kind of also show you, we can go to like Google and it still works browsing using the opposite computer's internet, and that's actually really fast. That's actually really super fast. So to be able to browse the internet with another computer's internet connection so flawlessly, and with so few lines of code as well, guys. I mean, I can't imagine having to write this out in like C or C++. It would take you like 5 years. But in any case, I really hope you enjoy the video. Like I said, leave a comment, like, subscribe, and thank you for watching. I will see you guys in future videos. Until then, happy coding. Peace out.